Hey guys, good morning. The first thing we're going to look at today is volume and surface area. And hopefully my pen will work today and won't quit working halfway through. The very first thing I would like you to do is complete this warm up. So you might want to pause this video, do the warm up, and then come back to the video because I'm going to go through the answers. All right. I'm going to try and do it in this little space here. Find the angle. All triangles add to 180, so just subtract 33 and 52, and you end up with 95 degrees. This is all information you'll need to know moving on in this next unit and what we're going to do in the next couple of weeks. Here we are looking for the length of AC, so if I label that X, I have an angle here, I have the side opposite, and I have the hypotenuse, so that is sine of 40 degrees equals 8 over X. When I do the math out and solve, I get X is approximately 12.45. Down here, find the area. It took me a little bit to realize that 15 is the entire length. I thought it was just that little piece right there. So this is just 1/2 base times height. So 1/2 8 times 15. Excuse me, had to sneeze. All right, so just 60 units squared, whatever we got. Okay, up here in number 4, back to a little geometry, you can either, recognize that these lines are parallel, and then corresponding angles would make this also 40 degrees. And then subtract from 180, that makes alpha here 140 degrees. Okay, and then if we expand this little triangle a little more, this is 55, this is 40 from vertical angles. Subtract from 180, you get that this is 85. So this little piece here is 85, so this piece here is 85, and then with corresponding angles, this piece is also 85 degrees. So alpha was 140 degrees, beta 85 degrees. Remembering those fun geometry formulas. 5, I'm going to have you omit. I probably should have said that to begin with, just because what we talked about the other day, we haven't done a lot with bearings. Find the volume and surface area of the cylinder. You might have had to look up that formula, but the volume of a cylinder is pi r squared h, and the surface area of a cylinder is 2 pi r squared plus 2 pi rh. Then it's just a matter of plugging into these formulas. Pi times 5 squared times 20. You get about 1570.8 centimeters cubed. And plugging into this formula for surface area, you get 2 pi times 5 squared plus 2 pi times 5 times 20. Which ends up being about 785.4 centimeters squared. So hopefully you were able to do that warm up okay, and that will help you moving on into what we're going to look at today. Here are the formulas that we're going to work with today, specific 3-dimensional solids, and this is part of the curriculum. It kind of ties in, it could tie in law of sines, law of cosines, the geometry aspect to the IB curriculum, things like that. So we've got sphere, volume and surface area, cone, and then a pyramid. All shapes you've seen before. So now we're just going to literally apply these to some examples. Example 1, find the surface area of the hemisphere shown. Well, first of all, a hemisphere is half a sphere plus a circle, right? So we've got the sphere part up here, and then we've got the circle down here. So you have to take into account both parts. So looking at our formula sheet, a sphere, and we're doing surface area, would be pi r squared. 4 pi r squared. So we would have 4 pi r squared, and we're dividing it by 2 because we have half of it, and then adding the area of the circle, which is just pi r squared. So just plugging in 4 pi times 5 squared divided by 2 plus pi times 5 squared. Put that all in your calculator, or don't. You get 75 pi if you don't, and that is about 236 centimeters squared. So a lot of this is just being able to visualize, figure out what parts you need, plugging into a formula. Hopefully this isn't too bad for you. The following shape models an ice cream as a hemisphere attached to a cone. Find the volume of this shape. All right, so hemisphere volume is 4/3. Well, we need first of all, we need a cone plus half a sphere. And we're doing volume. All right, so the volume of a cone is 1/3 pi r squared h, which is back in our formula sheet, 1/3 pi r squared h, and then plus we've got half a sphere. All right, and a sphere is 4/3 pi r cubed. So we would have 4/3 pi r cubed, and then a half of that, because we just have a half of the sphere. All right, so just to clean that up a little, this is 1/3 pi r squared h, and this becomes, because we've got this cancels into this, 2/3 pi r cubed. But you could have, gone ahead and done that out if you wanted to do it that way. So that's 1/3 pi 2 squared times 10 plus 2/3 pi 2 cubed, which gives you 56 pi over 3. Plug that into your calculator and you get about 58.6 centimeters cubed. So make sure you realize if you're looking at volume or surface area, obviously, that's going to be a big difference. And make sure you have the radius and not the diameter, because if you have the diameter, you need to cut that in half because most of these formulas are working with radius. All right, so the last of these problems is going to be a little more tricky, at least for me, because taking apart three-dimensional figures is a little more challenging for me. But this might be great for you, all of you visual learners. So the first thing we're going to do is find the surface area. And to find the surface area, you need the area of each of the sides. So the first thing we need is each triangle side. Okay, so meaning like here is a triangle, right? Right there is a triangle. So I am going to draw that here somewhat nicely if I can. And I know that each of these sides is 6, and I know that this is 2 and 2 because I've got 4 across the bottom, and I need to find the height. All right, so to do that, I can just use Pythagorean theorem. H squared plus 2 squared equals 6 squared. So h squared plus 4 is 36. H squared equals 32. So h is the square root of 32. And if you remember all your properties of breaking down radicals, that's 4 root 2. All right, so I have an h of 4 root 2, and now I can find the area of that triangle. 1/2 the base, the whole base, which is 4, times 4 root 2, which is the height. And that gives me 8 root 2 for one triangle. All right, and the area of this whole figure would be 4 triangles plus the square base. So we're going to do 4 times 8 root 2 plus the area of the base, which is just 4 times 4. And we end up with, if we put that in our calculator, 61.3 centimeters squared. So I think surface area is a bit easier just because we can find the area of each piece and then go with it from there. Now, volume I think is a bit trickier, at least for me, because visually it's just a little harder to draw. So the first thing we need to do for volume, if we look back at our formula, we need 1/3 the area of the base, that's what that large B is for, times the height. And if you look at this picture right here, the height is the perpendicular from the top. So coming back down here and looking at this picture, I'm going to erase this for a minute. We need to draw this perpendicular that's going to come to the middle of there, and that's what we need to find. So that's what first thing we need to find. Where did my volume piece go? I don't know what I did. All right, here we are. All right, let's come down here. So for volume, we need the perpendicular height and the diagonal base. So we need that, and we need this. I was going to attempt to redraw that figure, but I don't think that's the best since my three-dimensional drawings aren't good. But yeah, we need the diagonal across the base, and we need the perpendicular height. All right, so that's what we need. I was going to go ahead and write 1/3 base times height down here. All right, that's what we're looking at. And that means area of the base. Okay, so if we look at that triangle that I'm trying to represent three-dimensionally, we end up with this. All right, we've got a 6 here, we've got an H here, and this is D that I was representing above. So in order to find D in this original picture, we've got a right triangle here, okay? So we've got 4 squared D squared is going to equal 4 squared plus 4 squared, which will just be root 32, which again is just 4 root 2. All right, so that is our diagonal. So that means that each piece of this right here is 2 root 2, and then we're able to find the height from that using Pythagorean theorem again. So we would have h squared plus 2 root 2 squared equals 6 squared. All right, so h squared plus 2 squared is 4, root 2 squared is 2. So we end up with h squared equaling square root of 28, or h equals square root of 28. All right, and that is 2 root 7, just for your, because remember this is root 4, root 7. All right, so now we actually have our height, which is what we needed. That is this right here is 2 root 7. All right, and hopefully for all you three-dimensional people, this is visually working out okay. All right, and now we have everything we need to find the volume. So the volume is going to be 1/3. The area of the base is just 4 times 4, and then times the height, which is 2 root 7. All right, and this is 28.2 centimeters cubed when you put that in your calculator. I went ahead and put a video online with another example just like this with just a different perspective. It's just a guy showing a different example, and he actually draws all the different pieces, so that might help you visualize it. And hopefully that'll be helpful for you. I think it's for this example, this homework problem, and I wanted to just have another example for you. So I went ahead and put the homework assignment in Schoology, and it's these problem numbers, and you're just going to do them out, show your work, take a picture of it, and put it in the Dropbox. All right, guys.